Okay, these are our 1.2 alternate examples, and I think what you're going to start to see in this section is we're going to dive a little bit deeper into using the calculator and technology to really summarize. Between section 1.2 and 1.3, we're going to gain a lot of tools. So if you're not real familiar with the calculator, not really comfortable with it, I would recommend having like a notebook handy. Doesn't have to be a regular notebook that you use, but just somewhere where you're going to jot down keystrokes, just to remind yourself of where to go for certain common situations. So we're looking at the same set of frozen pizzas in both of these. The first example gives us the amount of sodium in milligrams, right? So those are different numbers, 580, 740, and so on. Down below, they've created a dot plot for us already. And what the dot plot does is basically gives us a number line, and then we have a visual representation of where these numbers live. And for example, like right away I can see, well, it seems like the center, or about the average of the distribution, is somewhere, between 700 and 750 milligrams of sodium. I can also see that I have 3 observations at 850 that all have the same amount of sodium. So the dot plot helps us in that regard, but sometimes it can be overload if we have too many numbers to try to look at a dot plot or to even construct one. If you have the TI Nspire, this is sort of your default graph that the calculator, when you go to graph single variable data, it will make the dot plot. It's pretty neat and definitely helpful. So now I want to move on to the second example where we're looking at the calories in the frozen pizza. Okay, and this is a really typical question that you're going to see. You might easily see this on an AP exam. Describe the shape, center, and spread of the distribution, and then we're going to talk about how do we figure out if there are any outliers. Okay, an outlier is a number that falls significantly far from the middle of the distribution, or what would be, average or normal. Okay, so when we think about shape here, if you looked at your slides, the shape here is roughly symmetric. Remember, if you have a long tail to the left, or a number that falls really, really small, we say that that's a skewed left distribution. Or a number that falls really far to the right, that's a skewed right distribution, or if there's a long tail in either direction. And I'll give you another tool that I think might be even more helpful to analyze the shape than a dot plot. Now, I do see to the left there, the 260 looks like, if there is an outlier, that one might be it. I think 260 is more likely to be an outlier than the 380. So if anything, there could possibly be a tail to the left here, and we could possibly say it's skewed to the left. But with my eye test here, it doesn't seem significantly. Again, when we talk about symmetric, it doesn't have to be perfectly symmetric, just generally symmetric. And again, I'll give you another graph that we can look at that I think will be helpful. I'll show you what I mean. So for this shape, and you want to be careful when you talk about this. You want to try to speak in complete sentences. So generally what I advise with my students is write a sentence about the shape, complete a thought about the shape, complete a thought about the center in context, and then complete a thought about the spread. So we want to think about what are the ways that we can measure spread, and we have a couple of tools for that now. You have the range, you have standard deviation, and you have the IQR, or the interquartile range. Those at this point would be values that we can use. And I think in the next section we get a little bit more in depth into what standard deviation measures and how to think about that. So for now, I'll just use the range, or the interquartile range, the IQR, to talk about the spread. So the shape, a complete sentence there would read something like the number of calories in Okay, so that's the shape. It's either symmetric, skewed left, or skewed right. We'll try to stick to those. Sometimes if you have 2 peaks, we could say that's bimodal, but we don't have to get into that much depth. I try to major on the majors and say, look, it's either skewed left or skewed right, or it's roughly symmetric. I'll use that word roughly a lot. The calories are centered around, looks like, 330 milligrams, or I'm sorry, 330 calories, not milligrams anymore. And we go 380 minus 260, that would be 120. So I answered all three of their questions. I talked about the shape, I talked about the center, and I talked about the spread. Are there any outliers? So I'm going to show you the 1.5 IQR rule here, sort of the real technical way to do it, but I'm also going to show you that you can use your calculator to really assist you in that. So on your graphing calculator, and if you have an Inspire, you basically going to have to go down to the, you have different programs you can kind of open on the Inspire. You would want to open your spreadsheet on the Inspire. And every time you do that, I want you to think of it like it's an Excel sheet or a computer program. If you put a list in, you have to label the list. In some ways, the 8384 is much more user-friendly, but then, the Inspire, what you lack in user-friendliness, you gain in some of the really neat things that it can do. So if you have the Inspire and you're really struggling with how to make these things work and get your data into the calculator, maybe you can check in with me in a WebEx meeting or office hours, or even in one of our live sessions, and I can set you on the path there. I probably have videos on any videos I make here. I probably have them all on my YouTube channel for every version of the calculator anyway. So on the 8384 type of calculator, what do you want to do? Write a note to yourself. Okay, the name of this class is statistics. Most of the time you're going to hit this button that says stat. So I hit that stat button. And what I want to do when I have a list of numbers is edit. So I'm going to hit stat, and the very first thing that's highlighted is edit. And what I can do is I can take all those numbers that are in that list, okay, the 340, 340, 310, and so on, and I put them in a list in my calculator. So you're going to want to do that first, okay? Pause the video now if you need to, if you want to get caught up to me and on pace with me. Don't just go down to this 340. Put all of the numbers in this list. There are, I think, 16 of them. Put all 16 numbers in the list. You can pause the Edpuzzle if you need to right now to enter them. All right? Once I have them entered, okay, a couple of things that you want to be able to do right away. Again, press the stat key. I'm going to live on stat. This time I want to calculate some things. Okay? I'm going to right arrow over to calculate, and I want to use this one variable stats key. Okay? If you have a much older calculator and it doesn't give you this pop-up menu here, I'll show you what to do in a second. If you have this menu, we're not going to do anything with the frequency list just yet. I'll show you what that means later. And I'm just going to hit enter and calculate. If you have an older version of the calculator, then your screen probably just looked like this. One variable stats, and then what you to do is tell it to do the one variable stats for L1. The way you enter that is second and the number 1. That'll put the L1 on your screen. Okay, so I press enter now, and look what I get. I get the mean, 328.75. I don't have to worry about these summations. This SX number here, 28.95, real helpful measure of spread. We'll talk about that more in the next section of the chapter. But this number here means that on average, if I randomly select any one of these 16 pizzas, I can expect the calories in that pizza to differ from 328.75 by about 28.95. Okay? The second, this is your population standard deviation. This number assumes that we have all of the pizzas in the entire population, which we don't, and we generally never have. And now you have your 5-number summary. I'm going to come back to this in a minute. This is the lowest number. It's 260. This is the median. Most of you are probably familiar with that measure. It's just the number that lives right in the middle. Since there's 16 numbers, I would take the average of the 2 middle numbers to get that. And then I have my Q3, and then I have my max of 380. Okay, that's my 5-number summary. So I want to talk about that again in a second. This time, I want to get a graphical representation of it. It's not going to be a dot plot like what we had before. I'm going to hit second and y equals, right? If you took algebra, pre-calculus, a lot of times you were probably graphing functions and equations using the y equals button. Well, this time we want to plot statistics. So you're going to hit second and y equals, all right? And you get a menu that looks like this. You want to check and make sure all these plots are turned off. Otherwise, things can go sideways in a hurry. I'm only ever going to turn on, most of the time, just one plot at a time unless I'm doing something kind of fancy. So I'm going to press enter, okay? I need to press enter again so that on is highlighted, not off, okay? And the plot that I want is over here. See how these two plots right next to each other look very, very similar, this one and this one? They both are box plots, but you want the first one. You want to highlight that because that's the modified box plot. What that does is that if there's an outlier, it will flag it for you, which is really helpful to us. Okay. So now here's another magic keystroke you want to write down. If you didn't already remember, it was second y equals to turn the plots on. Now write this down. To look at the graph, you're going to hit zoom and the number 9. Zoom for stat. So I get my box plot and look, check it out. Pretty symmetric box plot, right? It's roughly symmetric, pretty balanced. But we have this outlier to the left. So if anything, we could say this is skewed left if we brought that tail all the way to the left, or generally what I would suggest to somebody is that it's roughly symmetric with one low outlier. I think that's the best way to summarize that. And we had to check to see if the outlier was flagged first. So if you see what I wrote here, it's roughly symmetric, and in the second part, are there any outliers? I could say it's roughly symmetric distribution with one outlier at 260 calories. And notice that I keep reusing the word calories, right? Calories, calories, calories. It's really, really important that every time you answer a question for me or an AP exam, that you keep it in context. It's a simple thing to do, but it's also a simple thing to forget, and we can get complacent and think to not do that. All right, so now what I'd like to do is show you this 1.5 IQR rule so you can see how that fleshes out. And in order to do that, I need those one variable stats that I had before. Show you what I mean there. So the IQR is the middle 50%. It's the distance between 345 and 315. Okay, so what's the distance between 345 and 315? That'd be 345 minus 315. Let's take a look at what that looks like. So I take 345 minus 315, okay, and that is 30. All right, we call this the 1.5 IQR rule because this is my IQR. It's not the range, it's a max minus a min. It's the Q3 minus the Q1. It's the middle 50%. 50% of the data lives between 345 calories and 315 calories. So that's a distance of 30 when I subtract those two. So what I do with this 30 is I multiply it by 1.5. It's just a rule of thumb, but it's the same rule that your calculator uses. And what I get there is 45. Okay, so what I'm going to do is I'm going to add 45 to 345, right? I'm going to go to the Q3, the high limit, and add 45 to that. That would put me at 390. So I look at my list and see, do I have any numbers above 390? If I have a number above 390, it's an outlier, but I don't. Okay, now I'm going to, so what I did here was I added 45 to that, and over here I'm going to subtract 45. So where does that put me? It puts me at 270. So any number that is going to live below 270 is going to be an outlier, and that's why 260 gets flagged as an outlier. So my upper cutoff for outliers would be here. There's nothing above it. My lower would be here, so that's why that 260 is an outlier. It's a rule of thumb, but it's also the rule that your calculator uses when it flags outliers for you. So we do have one outlier, and we mentioned it here at 260 calories. Okay, so here we have two more dot plots. The first one, we're rolling a die 100 times. And notice, certainly we do have the highest peak at 5, but those differences, and it's described here, are negligible. If we rolled a die many, many times, it's a 10-sided die, we'd expect about each number to occur equally often, about 10 each, right? It's not going to be exactly that many. That's the idea of understanding inferential statistics. We base our inferences on what would happen in the long run. So 100 rolls is definitely a lot of rolls, but it's not as many as 1,000 rolls or 10,000 rolls. As we get closer and closer to 1,000 or 10,000 rolls, we'll get closer and closer to what's called a uniform distribution, everything occurring most often. Now we have a much smaller data set here of fiber in pizza, and this would be skewed to the right? I have a peak here at 2, and look, this tail drops off to the right, so we would say that that's a skewed right shape. Okay. Now we're going to compare the amount of energy costs for refrigerators that have freezers in the bottom and freezers in the top. and I want to write a couple of sentences comparing them. So remember, we want to write complete sentences. So I would probably write one sentence that compares their centers, right? One sentence that compares their spreads, and one sentence that compares their shapes. That would be, for me, a good way to chunk this up and think about it. So we always want to think about center, shape, and spread. When they say compare distributions, think to yourself about center, shape, and spread. So for, let's start with center. That's the easiest one. It seems that in general, the bottom freezers seem to cost more because they are centered around, looks like $70 per year, while the top freezers are centered around, looks like $56 maybe. So think about what I said there. I'm being really very specific. I'm comparing them and saying the one seems to cost a little bit more, right? The distribution bottom freezers has a much larger spread. Okay, it looks like it might be over 100. While the top freezers have a range of about, let's see, that's 56 goes over 70, counting by 14s. So maybe down to 7, like 50 up to 60, you know, range of around more like $15, I would, if I had to estimate. Okay, so much larger spread. And then finally, the shapes. The bottom freezers are skewed to the right, with 2 possible large outliers. I always like to mention the outliers if they're there. While the top freezers appear to be roughly symmetric. Okay, it's a lot of writing. It's a lot more writing than you're probably used to typically in most of your math classes. Okay, it's one of the things I think that makes this class challenging, but I also think it's one of the things that makes it very interesting because everything has an application and we're specific about it. So I really appreciate that about statistics. It's not as abstract as a lot of other math that you might study in high school. Okay, so here we have what's called side-by-side stem plots. Okay, and they give us a key for it. So this is the same data for the male heights, but just observe what they're doing here. This height of 154, 157, they're represented right here, 154, 157. There should be a 151 somewhere in here. If we look around, we'll find it. Yep, right here is 151, and there should be a 159 somewhere in there, right here, okay? That's what this represents. Now, what did they do here to come up with this? This row of numbers here is only going to be any number that's from 150 to 154. Once we get to 155 to 159, we're going to load those in here. There's advantages and disadvantages to splitting the stems. That's what they're doing here, though, right? So we have 151, 154, and then once we get past 154, we would have 157, 159 here, okay? Just the male heights. We're not accounting for the females yet. We look at the females in the next portion here. We can scroll down and see. Now we go side by side, so we can compare these two. It's a really helpful comparison, right? I have 151, 154 for males, 152, 153, 153 for females, 157, 159, 157, 158, 158, right? I can see all these actual numbers in the stem plot, but I can also see the shape of the distribution. I can see this distribution here looks like it's going to be slightly skewed to the left, right? If we took this and stood it up, these are smaller numbers here. That's where that tail is going to the left, whereas the male heights generally look to be roughly symmetric. And if you weren't sure about it, you could put them in your calculator, make a box plot, and see, look at the shapes from that angle. Okay, so these are examples of histograms. This is these basically show you the same thing that those box plots show you, except, or the stem and leaf plots show you, except the stem and leaf plots you can actually see the actual numbers. I don't know the actual numbers that are in this, that are included in this frequency. I just know that they live between 93 and 95. And I don't know these numbers. I just know they're between 95 and 97. But I can look at the shape of the distribution. I can see this is kind of skewed to the right. Skewed to the right. Okay? Skewed to the right. Even though the class widths are different, I can still sort of see that shape. But with the stem and leaf plot, different data, I can actually see the actual numbers, but I can still see the shape. If you can see that, if I could take this and rotate it 90 degrees clockwise, you would see it's this. Well, I'd actually, the lower numbers would be to the left, but it would be skewed to the left because I have fewer small numbers than I do bigger numbers. Whereas the male heights seem to have a peak in the middle and pretty symmetric around that middle.